like this one, this bottle. And here is the reagent A and reagent B. Okay, before I start the calculation, let me have a short brief introduction. Like this one. And here, sanitizers. What are sanitizers? Generally speaking, sanitizers sanitize. This term. Sanitize. This term is about to kill bacteria. And I have a question. If you are interested, please write down those notes. Sanitize, disinfection, or disinfecting. Maybe some are verbs, some are nouns. Okay, and one term is called sterilization. Sterilization. Okay, my horrible English spelling. Okay. Sterilization. Okay. Okay, maybe I can use all. Sterilization, disinfection, and sanitizing. I like this one. Okay. What is the difference among those three terms? What are the differences among those three terms? Okay, in my language, because my major is food microbiology, I cannot say I'm an expert, but I'm this kind of background. Okay. First term, sterilization. What does it mean? Kill all bacteria, all microorganisms, including viruses, including fungi. Okay. The second term, disinfection. The meaning, according to my what I learned about the disinfection and sanitizing are the same meaning. Maybe it's different from the dictionary. Okay, let's check here. From this website, I don't know where is the website. Okay, the AI overview. Sterilization, disinfection, and sanitizing are all processes to reduce microorganisms. And here, sterilization destroys all microorganisms. Yeah, I like this definition. Sterilization kills all bacteria, fungi, all microorganisms. Sterilization. Why you emphasize this? Because there is a horrible tiny structure called endospore. Endospore is especially some pathogenic bacteria. The endospore is very horrible. Even you using cooking, boiling water for 1 hour, 2 hours, 3 hours, you cannot kill the endospore. You cannot. Maybe you can use UV radiation, ultraviolet, the UV radiation to kill maybe at least 15 minutes for the radiation. Sure, if you are interested, you are welcome to visit my lab. Because I'm the manager. I'm in charge of managing the laboratory in B810, at F floor upstairs. You are welcome to visit my lab. Okay, and also it's very horrible. And generally speaking, sterilization kills all bacteria, including endospores. But disinfection and sanitizing kill most. Here. Sanitizing destroys all microorganisms, including spores. Here, especially endospores. Because spores, there are two kinds of spores. Okay, sorry, here. fungal spores versus endospores. Fungal spores, the purpose of spores from fungi and bacteria are different because the fungal spore to generate the next generation, but for endospores, it to, how can I say, sorry, I forgot to say in English, when the bacteria suffers some dangerous situation, then the bacteria duplicate the DNA and try to use the less strength to generate some special material to surround the spore. Thus, the spore is very durable, very strong, and not easy to kill. And the fungal spores are primarily reproductive structure, and it's very easy to kill. Maybe boiling is enough to kill, but the endospore is not easy to kill. Even you boiled the water for several hours, the endospore can survive through the harsh situation. So it's different. It's different. Okay. And here, let's come back to the disinfection and sanitizing. Generally, disinfection and sanitizing reduces the number of germs to a safe level. Again, to a safe level. Why you say this? Because sometimes, for example, when we drink milk, and it doesn't need to be sterile. Sterile, it means no bacteria survive in the food or in the stuff. Okay, so now we learn the term sterilization, kill all bacteria, disinfection, and sanitizing. And now I want to introduce you this one. I prefer to call it sanitizers. Okay, let's come here. What does it mean? According to the Oxford Language Dictionary, a substance used to make something clean and hygienic. Sanitizer generally is a chemical compound or a group of chemical compounds. For example, ethanol, 75% ethanol is very common and said to use to sanitize your hands or your utensils, like this one. And sanitize for food. Sanitize for food, for example, chlorine-based product like sodium hypochlorite. Yeah, the same ingredient as we use the bleach to wash our clothes. And quaternary ammonium compound. Who knows this one? Quaternary ammonium compounds. I have a big tank, about 20 kilograms upstairs. If you have a chance, you are welcome to visit my lab. But don't worry, I will not operate any toxic compound. No, I did operate, especially the my friend with the biological background, you know that? Okay. This one is quaternary ammonium compound. It's very common use in food industry. And here, peroxyacetic acid, and all are here. And now I want to say one thing, that is chlorine dioxide. Okay, here chlorine dioxide is an effective sanitizer for food contact surfaces, equipment, and even food products like fruits and vegetables. And sure, in family cooking, generally we don't care about this. But if you have chance to buy the vegetable and salad in a convenience store. In a convenience store, small business, we don't talk about small business. About the big business, I mean the chain convenience store. They sell the salad and vegetables. They can be sanitized by chlorine dioxide, and the chemical structure is Cl and 2 oxygen here. It's called chlorine dioxide, and it's a broad spectrum disinfection that kills bacteria, viruses, fungi, and spores. Wow, spores. Okay, spores. We just mentioned this, and that is a powerful oxidizing agent. Oxidizing that does not produce harmful byproducts. Oh, it's good. It's good. That's a trihalomethanes. Okay, and why? But you may ask me, what kind of situation we will get the byproduct, the dangerous byproduct called trihalomethanes? Generally speaking, in our table water, in many countries, our table water system, we use sodium hypochlorite to sanitize our table water. And the trihalomethanes or methane, THMS, that the low concentration is okay, but that is toxic, that is carcinogenic. That is safe when used correctly and can effect against the organisms like Listeria, Salmonella, and E. coli. And you can use the liquid form for the surface and water treatment, or a gas for airborne sanitizer in processing facilities like this one. And we can see the yellowish color in the bottle. Yes, I estimate that the concentration inside is 600 parts per million to 800 parts per million here. And I just showed it when we open the cap. I can smell it a little bit like the bleach, but the smell is lighter, smaller. Who want to try this? Hi, Mr. Xu, want to try this? Smell it? Not too close then. The gas is chlorine dioxide, but personally, is the smell very close to bleach. Bleach in our language. Can you smell here? I think it's very sensitive. It's very just one reminder. If in the future, if you have a chance to work as a worker in the food industry, you need to tell your supervisor, I'm allergic or I'm very sensitive to some sanitizer. Otherwise, I will get asthma, something like this. So sorry, please let me know. And because there are some very few cases in Taiwan, the workers forget the correct SOP. They just place the reagent A and B together, and suddenly the the chlorine dioxide, the gas running out, and it will not kill people, but we feel uncomfortable when the concentration is high. Okay. All the gas for the airborne sanitization in processing facilities. And now I want to introduce it. Okay. I prefer to use information from Wikipedia. Okay, I'm going to copy and paste the information to you. A minute, please. Okay, here the chemical structure look like this one, one chlorine atom and two oxygen atoms, and the structure look like this. And here is the picture about the chlorine dioxide gas with yellow chlorine dioxide solution. Okay, and the name here, okay, that is called the IUPAC name is called dioxygen chloride, but generally we prefer to call it chlorine dioxide. This is the most common name we use it. And here chlorine 4 oxide. Okay, and here is the case number. Who knows case number? Case number. Okay, you can check it. You can. I will explain this by my language. In Taiwan, everyone has their own student number. Yeah, sorry, their ID number. I believe in Philippines you have your own ID number. In the American, they have the number called Social Security number, SSN. I had my own SSN in the US when I was a student. Because this number is specific for the person, right? Okay. And here, case number is the most common number identity, like the identity number for human. Here, the number is 1004904 and 4. Don't ask me, it's very ugly. No rules. No, don't worry about this. And here, later, if I'm interesting, I will show you here. Who knows smiles? Not this time, because I forgot to install the smiles. Not this. Smiles is I forgot the full spelling of this. Simplify the molecular input line entry system. Smiles. How can we see? If we have this one, you can type this one, copy and paste, then you will use appropriate software. It will generate that you need. Okay, for example, this one. For example, there is a very common and essential amino acid that is called tryptophan. Tryptophan is one of the essential amino acids for human. Tryptophan, and the structure look like this one. Okay, can you draw it? Look like this one. If you have chance, next time, not today, next time I will show you how to do this. There is smiles and show the smiles. You just need to copy and paste this ugly number or letters and paste on appropriate software. It will generate the structure automatically and with the correct structure like this one. Not today. Next time I will show you how to do this. Okay. So here, contact smiles is this one. How about inch? International Chemical Identifier. What's the difference between the smiles and inch? Smiles cannot show stereo isomers, but inch can do that. But that's not the point of today. Let's move here. And here, who knows LT50? Okay, here. Who knows this one? LD50. Hey, sure, you can see one label in the convenience store in Taiwan. You can see LD25. It's a brand of a cigarette. I'm just joking, but LD50 is very important in our field. But I think you can learn something about this. It's called a lethal dose 50%. Lethal, kill, to die, to kill. Lethal dose 50%. For example, if this one is toxic for me, how to calculate according to the animal tests? Just a little amount can kill 50% of the test animals. We call the concentration of the amount of the compound is LD50. LD50. Okay, let me show you here. I already gave you the website. You can check it. Lethal dose 50%. Median lethal dose 50%. Or lethal dose 50% or median lethal dose. Okay, the median lethal dose LD50. In other words, called the lethal dose 50% of a toxin, radiation, or pathogen is the required to kill half of the number of tested population after a specific test duration. Okay, here's the definition. And sure, for you, your background is business and economics is not important for you. But in our field, this concept is very basic and important. But it's easy. Okay, let's come back here. The lethal dose 50% is here. It means if your body weight is 60 kilograms and 60 times 94 milligrams, after this kind of eating or intake this amount of the chlorine dioxide, 50% of the population will die. Okay. I think I will ignore this part. Okay. Chlorine dioxide is a chemical compound with the formula ClO2 that exists as a yellowish green gas above 11 degrees Celsius and reddish brown liquid between 11 and minus 59 degrees. Yeah, that I will put it in the refrigerator. And as a bright orange crystal below minus 59 degrees Celsius, and is usually handled as an aqueous solution. It's commonly used as a bleach. Yeah, sure, bleach. There are several compounds. What I mentioned is about sodium hypochlorite. Okay. More recent development has extended its application for food processing as a disinfectant. Okay, the structure is here. Okay. The chlorine dioxide was first prepared in 1811 by Sir Humphrey Davy, and in 1933, this gentleman, a graduate student of Linus Pauling, Linus Pauling, he was awarded twice of the Nobel Prize, one for chemical, one for peace. And Linus Pauling was he had a hypothesis about hydrogen bonding. Okay, a very famous chemist proposed a structure that involved 3 electron bond and 2 single bonds like this one. Okay, I will skip this part. Preparation. Okay, the preparation and okay, here, not this one. Okay, here. Okay, in our system, we use this one. We use this one. The reagent B is sodium chlorate. Sodium chloride. This one, reagent A. The reagent B is hydrochloric acid, HCl, like this one. When mix them together with the same volume, it generates 5 pieces of sodium chloride and 4 pieces, 4 times of chlorine dioxide and water. Okay, so we use this one. So today, copy. Okay, the formula we see today is this one. Again, 5 times of sodium chloride and 4 times of hydrochloric acid, and we get the chlorine dioxide. Okay, and now I want to say something here. Oh, sorry, I misspelled it. Okay, let me have this one. Here is the food safety news. Is one of the major sources to prepare food safety handouts for safety information here. Okay, then chlorine dioxide, the last line of defense in sanitizing food processing facility. Sanitizing as part of preventive control is a requirement for food processing facility, but when microorganisms like E. coli, Listeria, Salmonella, Staphylococcus aureus, here is a typo. The A should be in lowercase, not in capital. Okay, and other persist chlorine dioxide gas may be the best key step for resetting the environment. Okay, let me skip this one. And sure, here is the advertisement. Okay, and here in food in industry, how to prepare chlorine dioxide. Chlorine dioxide is always treated on site or in food processing facility immediately before the use, as the helper demonstrates the use that because it's unstable and potentially hazardous gas that cannot be compressed, stored, or transported under pressure, and the specific preparation method varies depending on the application, gas, liquid, or smell. Okay, and now tablet. You can buy this tablet, just one tablet. According to the menu, you can prepare a little bit of table water and dissolve the tablet into the. But I cannot buy the food grade chlorine dioxide from Taiwan because some product made in China, I don't think that's reliable. Thus, I buy those. We call it reagent A plus B. In Taiwan, we call in our language we call it reagent A plus B. The method. Sure, you can buy one tablet, very small, very tiny, like the vitamin pill, and you can dissolve it in 1 liter or 5 liter. And for the environmental sanitizing. For example, after the flu or COVID-19, you want to sanitize the environment or the classroom or your living room in your home, you can use this one. You can spray it or open it, that the gas is running out, and it will sanitize the environment. Reagent A and B. reagent A and B. It didn't have exact number like this one. Okay, sorry. Let me use my language. Oh, like this one, but it's not for food industry. The reagent A and B you can prepare it right before you need to use it. And like A and B, like this one. Okay, and so far, how to use? How to use this? Chlorine dioxide to sanitize fruits. For example, dilute 2 parts activated solution into water, sunk the produce for 1 to 5 minutes. Then rinse it thoroughly with clean water. But there is a question: where to get clean water? We ever tested the table water from our campus, and it's not sterile. We found some bacteria spots from the table water. Again, so the table water, maybe the bacterial number is not high, but it's not sterile. The table water in Taiwan has bacteria inside. How to rinse it with the clean water? So do you remember last class, the second orange tank here? The lady prepared 1 parts per million of it. Okay, let's come back here. Someone calculate it correctly, and now let me show you how to do this. How to prepare from the original concentration 30,000 parts per million to 20 ppm. The volume is 20 liter. There is an equation, C for concentration. Concentration 1 multiply volume 1 equals concentration 2 times volume 2. Whoever learned this formula? Okay, no problem. How about the other students? Okay. I explain it as original concentration times original volume. That will equal to the later concentration and later volume. Original concentration, that is 30,000 parts per million. And the original volume, we didn't know. I use V1. After dilution, the concentration will be 20 parts per million. And the volume will be 20 liter. But I will convert the 20 liter into 20,000 milliliter. Is it okay for you? Okay, then at the calculation, V1, the volume will be 20 parts per million, 30 parts per million, 20,000 milliliter. Okay, let's cancel. Unit ppm, and 30,000. 20,000. To simplify it, (13.333 milliliter). Yeah, someone get the correct answer. Someone got the correct answer. So I suggest the lady, Miss Lin, prepare 13.5 milliliter individual for reagent A and B separately. Okay. Second question: how to prepare 1 parts per million?
1 times 20,000.
20,000.
Divided by 30,000.
Can you say that again? I can again. Sorry.
I try. Volume 1 equals to 1 times 20,000 divided by 30,000, which equals to 0.267.
Okay, you are correct, but sorry. Go ahead.
Yeah, 2/3 for ml.
Okay, you are correct, but it's not easy to take the exact number, the volume, very small, less than 1 cc, right? 1 milliliter. Okay. So I told my student how to prepare this one. Just a hint. From the tank, there is 20 liter of 20 parts per million. How much you can take and dissolve it? The final volume is 10. Sorry. Get it? Prepare 9.5 liters of tap water. Then transfer 500 or 0.5 liter. The same volume. 0.5 liter of this concentration. Mix it into this tank. Then we get 10 liters of 1 parts per million the chlorine dioxide. Is it okay for everyone? Oh, come on! You don't need to take picture because I'm live streaming now. You can check my video. Sure. Again, we have no exams. Okay, we no exams, and I just share my experiences how to calculate it. Okay. Just 2 minutes to finish our course. Any question? Okay. Some students are late for our class. Please come to see me. I will check the attendance again. Okay. See you next week. I hope I cannot promise next week we can have the fruit drink or muffin. But I will ask my student to do that. Okay. See you next week.